I'm Doug Fern, and this is my take on music recording. Ideally, we would all record in a great studio, but often we have to make do with a room at home or record on location. How do we make this space sound as good as it can? What can we do to make it work effectively? We know that great sounding records have been made in home studios, going back to the real pioneer in this, Les Paul. In the 1950s, Les Paul converted his garage into a studio and equipped it with an Ampex 8-track tape machine, one of the first ever made, and made records unlike anything anyone had ever heard before. You could say that Les Paul invented the Project Studio. If he could do it 70 years ago, you can do it today. First, let's talk about where you will record. You have a couple of options. You could record on location in a concert hall, church, or other large space that has nice acoustics. This can be a viable choice, especially if you need a room bigger than your basement or garage or bedroom. But it means hauling gear to the space, moving it in, and setting it up, even before you start any recording. That's a lot of work. Unless you are familiar with the space, there may be some acoustic surprises. And often the space is only available for a limited amount of time, or you might have to pay to use it. If you need to record a string or horn section, on location may be your only option. Well, unless you want to rent a real studio for those overdubs. More likely, you'll be recording at home. That's a lot more convenient, especially if you can set up a recording environment and leave it set up for an indefinite period of time. The problem is, of course, that most of us do not have big rooms to use for recording at home. And that puts a limitation on just how good we can make it sound. My recording space has evolved over the years and now straddles the line between improvised space and a small professional studio. For many years, I had a real professional recording studio. It had a big room, acoustically very nice, and a separate, spacious control room. There was space for a machine room, a separate room for the EMT reverbs and other gear you didn't have to get at all the time, and separate dubbing rooms, which could double as simple studios when needed. The facility even had a disc cutting room. I miss that facility, mostly because of the great sound of a big room. As you probably know, I started a new business in the early 1990s for manufacturing the studio products I designed. My products were really developed to fill a need I had for better gear than I could find. But that's another story. The manufacturing business started out based at home, which was fine until the business started taking over the house. After considering the options, my wife and I decided it would be best if we designed a new house with the ground floor devoted entirely to the business. All the assembly work was, and still is, done by really skilled and dedicated craftsmen who worked at home. But all the parts were stored in my facility, and with 12 products in the line, there were a lot of parts. Most of my space was devoted to part storage, along with my shop, where I developed new products, and space for the final testing and listening before every unit was shipped to the customer. And then a few years ago, I licensed the manufacturing of my products to Joff and George Hazelrig of Hazelrig Industries. Joff had worked for me for many years assembling D.W. Fern products, and now they have all those racks of shelving filled with the parts to build the products. And I have lots of space open for recording. Actually, I started using the space while it was still filled with metal shelving, and it sounded pretty good. I used the shop as the control room, but the space did not look very good, and the process was similar to doing location recording because nothing could be left set up in between sessions. That raw space was about 25 by 35 feet with a 10-foot ceiling. That's not much smaller than some professional studios, but still not nearly big enough to do a big session. And, of course, it does not sound like a large room. I also have a large garage within the building, larger than a 2-car garage. It's about 21 feet by 37 feet. That was useful for a drum room or other isolation of vocals, electric guitars, etc. Of course, it sounded like a garage. But rather than fight that sound, I decided to embrace it. That was fine for some types of music and terrible for others. I improved how it sounded, temporarily at least, with some sound-absorbing materials. In the main studio area back then, the rows of shelving were filled with lots of cardboard bins filled with small parts, and large areas filled with metalwork assemblies. This actually helped the sound of the room significantly. There was considerable absorption from the softer stuff and a lot of diffusion from the shelving and harder parts. On my podcast website, dougfern.com, there are photos of the space showing how it evolved over time. I also wanted to use the space for shooting video for my YouTube channel. It was a challenge to make it look presentable, and for some of the videos, I didn't even try to make it look better. The focus was on the topic of the video. When I finally had the space cleared out, it was time to improve the acoustics, the aesthetics, and the creature comforts. Along the way, it became apparent that I needed a real control room. I know many people are fine with being in the same room as the performers, but it was difficult for me to work that way. For one thing, you never know what you are getting, or if there are any problems, until the take is done and you listen to the playback. Most of the people I record have very busy schedules and or have to travel a great distance to record. Time is critical, and most sessions are less than 3 hours. I couldn't afford to waste the time waiting to hear what we got, so a real control room was a priority. If you are recording yourself, or you and some friends, that might not be an issue, and you can all be in the same space. I've done sessions like that, and it certainly makes communications a lot easier. But on balance, I wanted a real, isolated control room. Well, let's move on to how you can optimize your space, no matter how you are going to work. There are some basic acoustical principles that apply no matter how big or small your space. We'll start with the size and proportions of the room. As a general rule of thumb, the bigger the space, the easier it is to make it sound good. This is really important to realize. Conversely, the smaller the space, the more of a challenge it becomes. Even if you do not need a lot of room for your projects, a bigger space will make your life a lot easier and your recordings will sound better. But most of us do not have that luxury, so we have to make do with the space we have, which is always going to be too small. The proportions of the room will be critical. That is, the ratio between the height, width, and depth of the space. Why? Well, between any two boundaries there are going to be certain frequencies that are emphasized or lacking. That is physics and cannot be changed. Even in the most sophisticated rooms, the proportions, in large part, determine the intrinsic sound of the room. If you have the luxury of specifying the dimensions of your space, you can optimize the proportions to give you the best possible distribution of these exaggerated frequencies. Small rooms will have those resonant frequencies right in the mid-range, where they will almost certainly be obvious and probably sound bad. You know the sound: tubby, muddy, lacking in clarity. Designing a room from scratch with enough flexibility in the space can make even a fairly small room sound acceptable. You can find online formulas, calculators, and design suggestions for good proportions. The worst possible room is a cube. That will never sound good, no matter what you do to try to correct it. Not many rooms are cubes, fortunately, but a lot of construction in the last 70 years or so utilize standardized building materials, which are usually multiples of 4 or 8 feet in the U.S. That applies to both houses and commercial space. It's just cheaper, faster, and easier to build rooms that do not require cutting materials like drywall. The problem is you end up with rooms that are acoustically problematic. For example, a typical household room might be 12 by 16 feet with an 8-foot ceiling. That's going to have room resonances or modes that are very obvious, and it won't sound good. It's much better to pick dimensions that won't cause those frequency anomalies in the first place. Calculating this is much simpler than it was in the old days when you had to do all the math by hand. For example, my control room was, by necessity, very small. The room is about 13 by 10 with a 9-foot ceiling. That was the best I could do in the space available, and it worked out pretty well. You're actually hearing that room now on my podcasts. When the room was completed but empty, with just a concrete floor and heavy multi-layered drywall ceiling and walls, it was very reverberant, as you might imagine. I went in there and closed the door, clapped my hands to hear how the room responded, and it sounded very smooth, just like the calculations said it would. It's not a great control room, but it is about as good as possible for its size. There is a video on the D.W. Fern YouTube channel that documents the entire process of building my control room. So if you have the ability to build your studio or control room in an existing space, spending the time optimizing the dimensions will be worth it. Interestingly, the actual boundaries of your space may not be what you determine with a tape measure. How can that be? Well, in typical home construction, with thin sheets of drywall on a wooden framework, the walls are not very soundproof. You know that if somebody is talking in an adjacent room, you can hear them, but the high frequencies are missing. The bass frequencies go right through the wall. Those construction materials do not stop low frequencies, so the actual boundary for lows may be many feet beyond the wall. That can make your small room sound better than you might expect, given its size. That virtual dimension is difficult to calculate. Which leads us to the concept of soundproofing. Let's start by saying that nothing is really soundproof. It's a matter of degree. And let's dispel a myth. Sound-absorbing materials like fiberglass insulation or drapery, or moving blankets, do not provide any significant blockage of sound. Think about it. If you held up a piece of insulation and talked into it, could a person on the other side hear you? Of course they could. Your voice would be muffled since high frequencies are being absorbed by the material, but it does not stop sound. The most materials like that can do is attenuate the high frequencies by a few dB. What you need to stop sound is mass, thick, heavy walls made of dense materials like concrete or brick. And the wall has to be tightly sealed. Even a tiny gap in the wall will degrade the soundproofing significantly. You might lose half of the sound isolation. But is making a space soundproof even necessary? Well, maybe you live in a very quiet environment and are not bothered by traffic or neighbors. In that situation, you can get away with minimal soundproofing. But most people live in places with an unavoidable amount of background noise, which can vary quite a bit from minute to minute. If you're recording yourself, you might be okay with an occasional retake because of an interfering outside noise. That would be inexcusable in a professional studio. Another soundproofing factor is bothering other people with your music. This could be your neighbors or other people in your home. Many musicians like to work at night, which is often quieter than daytime, but is also when you're most likely to bother others. Soundproofing works both ways, so you have to consider your situation in the design stage. When I design a studio for someone, I meet with a contractor and tell them that when we are finished this job, we're going to fill the room with water, and if it leaks, you don't get paid. Funny, sure, but it makes the point. And you can't just seal the gaps with caulk or tape or molding or paint. Whatever seals the gap has to be as heavy and dense as the rest of your wall, or else you're wasting your money. Well-designed professional studios use heavy concrete or brick walls, and that's expensive. Abbey Road studios in London are isolated from each other and from the outside world with massive double brick walls. These walls are inside the building's outer walls, and they use the bricks end-on, unlike the usual form of brick construction. And there's 2 layers of these bricks. They can run 3 studios simultaneously with near-perfect isolation, and never bother their neighbors in the residential area where the studios are located. Well, let's say we've solved the soundproofing problem as best we can. The next principle is sound absorption. This is an area that also has many misconceptions. Remember that sound-absorbing materials do next to nothing to stop sound. What they do is reduce the reverberation time of the room. Wait, you say, I don't hear any reverberation in my room. Probably you don't notice it, but reverberation is present in all rooms, except an anechoic chamber. The sound bounces around your room whether it is obvious or not. It's not going to sound like a concert hall or church, but your room does have echoes. In a small room, the time delay between the sound and its echo is measured in milliseconds, thousandths of a second, instead of several seconds you would hear in a concert hall. Those reflections will influence how your recording sounds. Our hearing is remarkably capable of discerning these echoes. They help us, consciously or not, know how big the room is and what's in it. If you combine bad proportions and sound reflections in a small room, you often end up with a recording that sounds small. It may sound like a closet or other small space. It's going to detract from your recording unless you want that kind of sound. Absorbing some of the sound in the room will reduce the echoes. But what material to use? Many people think things like household insulation, curtains, or sound-absorbing foam will fix the problem. And to some extent they do. But these materials do not absorb all the audible frequencies equally. They absorb high frequencies much better than low frequencies. That results in a very dull-sounding room, often with prominent mid-frequencies emphasized. Absorbing mid and low frequencies is much more complicated. Absorbing lower frequencies requires a lot more depth of materials than the usual 3 to 5 inches used. An anechoic chamber, which has no reflections at any frequency, has absorbers that are many feet thick. Not practical at home, and even if it was, an anechoic chamber sounds terrible for recording. So you may have to live with the fact that there are going to be unpleasant emphasis on lows and mids. This can muddy up your recording, and no amount of equalization is really going to fix it. The ceiling is often the easiest place to add sound absorption. An acoustic tile ceiling is a start, but like many sound-absorbing materials, their effectiveness drops as the frequency goes down. Usually, however, there is space above the acoustic tile suspended ceiling, and you can use that space to add additional absorbing material. In my studio and control room, there's about 2 feet of rock wool insulation above the suspended ceiling. Absorption above also has an advantage for performers. Although our microphones don't really know where the sound reflections are coming from, our ears do. For musicians playing in the room, the lack of reflections from above sounds more natural. This may be because humans have spent most of their evolution living under an open sky, and our hearing has adapted to the lack of reflections from above, which provides us with a better sense of sound localization. Of course, performers wearing headphones may not notice the difference, but it does make the space more comfortable during the setup and run-through phase. And your not very soundproof walls might absorb a significant amount of the low frequencies simply by passing through the wall, never to be heard on the recording. But it's the mid-frequencies where most small rooms have their biggest problem. There are ways to trap some of these mid-frequencies using devices tuned to the problem range, but don't expect miracles from that approach, and be prepared to lose a lot of space. Am I making small rooms sound impossible to use for recording? There are ways to get around most of these problems, but it will certainly make you appreciate a larger room. One other technique we can use to improve our space is diffusion. This is simply reflecting the sound around the room in a random fashion. Rather than a hard, even surface of a wall, think of things that have random depth and angles. The easiest way to hear this at work is in a cathedral, where the sound echoes for a long time after bouncing off the stone walls. But most cathedrals have columns, side chambers, pews, and an arched ceiling. The sound you hear has bounced off all these different surfaces and merged into a pleasant jumble of reflections we call reverberation, as opposed to the hard echoes off a flat surface. Well, your spare room is not a cathedral, but you can still take advantage of random reflections using devices called diffusers. These can be purpose-built or even bought commercially, but you need to understand what they are and how they work. You may have a lot of diffusion already in your room, especially if there is furniture, bookcases, or other objects that can reflect the sound randomly due to their uneven surfaces. Or you can build your own diffusers. It's not difficult. There are several photos of different diffusers at the web page linked to this episode. Keep in mind that minor variations in the reflecting surfaces are minimally effective. As an easy approximation, sound travels about 1 foot in 1 millisecond, a thousandth of a second. Your hearing needs at least 5 to 10 milliseconds to perceive a time difference, which means, in theory, a diffuser has to be 5 to 10 feet deep to be effective. In reality, you don't need that much depth to improve the sound, but keep in mind that deeper the diffuser, the better it's going to work. And installing a couple of square feet of diffusion in a room is unlikely to make a dramatic difference. It takes a significant amount of diffusion area to help the sound. In my studio, in its early state, the rows of metal shelving and mostly random contents on the shelves provided a remarkably good sound. Also in the space were utility structures, such as a hot water heater, water storage tank for the well, and cylinders for a water conditioner. It was a wall of diffusion and helped a lot with the sound. Cylinders make great diffusers. Even a half-round object will help. Abbey Road Studio 2 is a large brick rectangular box with no dedicated diffusion at all. Yet it sounds great. There are sound-absorbing hanging structures to help control the high-frequency reverberation. And it is a room with a lot of stuff in it to provide diffusion. Several pianos, organs, Leslie cabinets, racks of folding metal chairs, many mic stands large and small, and even large rolling racks for headphones. All these things provide some diffusion. How about isolating the pickup of multiple instruments in your improvised space? You might need isolation because you plan to replace an instrument later, or maybe you just want good isolation so you can process that one sound without affecting the other instruments. Or you want a nice tight sound without the random bleed of one instrument into another. A Achieving good isolation between instruments in a small room can be challenging. By necessity, everyone is close together, and you might be recording instruments that are not compatible in level, such as a vocalist in the room with drums or electric guitar. You can help this problem in several ways. You can improve the isolation by placing sound baffles between the instruments. This can help to some extent. These baffles, sometimes called gobos, are typically a few feet high and covered with sound-absorbing material of some type. The interior of the baffle could be a solid sheet of material, typically plywood. These are easy to build. This helps at least the higher frequencies from being picked up by nearby microphones. Baffles can help somewhat, but generally their contribution to isolation is not dramatic. However, they can change the acoustics in the vicinity of the instrument and the microphone, which might be a big advantage. Another way to improve isolation is to use directional mics to reject the unwanted sounds. This can help, but don't expect miracles. Keeping the mics very close to the sound source will minimize the extraneous pickup if you want that close mic sound in your recording. Another approach is to use different rooms in your house for different instruments, keeping in mind the acoustical problems of soundproofing, absorption, and diffusion. Or you can record each instrument separately over time so there's never more than one sound at a time. All these techniques can be used as needed to isolate instruments or vocals. Just keep the acoustical principles in mind, so when you put everything together in the mix, it still sounds like you're recording in a believable acoustical space. Another approach to recording at home might be to make your space as acoustically dead as possible and close mic everything, so that there's no discernible sound of the room. This alone can be effective on some types of music, but mostly it's not a good sound, in my opinion. You need the sound of a real space to make the recording appealing, and this can be entirely subconscious to the listener or even to you. Adding artificial reverberation may be useful in this scenario. Other considerations for your improvised space include lighting and HVAC. Even if your space has good heating and cooling and nice lighting, these things can still affect the sound. Let's take the HVAC first. Obviously, it should not make any noise you can hear on the recording. One easy solution is to simply turn it off during recording. That's what I do in my studio. Of course, the space will eventually get too hot or too cold or too stuffy, so you might have to turn the system back on during a break. Another potential problem with HVAC is sound transmission through the ductwork. Even if you have done considerable effort to soundproof your space, ductwork can render that worthless. Sound travels easily through metal ducts, from room to room, throughout your house. And never let an HVAC contractor tell you that sound cannot travel against the airflow. That is ridiculous, but I've heard it often. The design of ductwork for sound isolation is complex, expensive, and takes up a lot of space. One solution, if the ductwork does not already exist, is to use a separate HVAC system for your recording space. This might be less expensive than you think, so it's worth looking into. If you have a separate studio and control room, they should be on separate HVAC systems, if you want reasonable sound isolation between the rooms. Lighting seems so simple. What could possibly go wrong? A lot, actually, and it's mainly because of the newer, higher efficiency lighting we use. Newer technologies like LEDs and the obsolescent compact fluorescent bulbs can be a significant source of electrical interference. Well-designed and properly installed professional recording equipment is largely immune to this electrical interference. but electric instruments, and even some microphones, will pick up the electrical static from these bulbs, and you'll hear it on the recording. It sounds like a hum or buzz, and it can be difficult to minimize after the fact. Incandescent bulbs, despite their efficiency and heat, never make any electrical noise. That's why in my studio, and in a lot of professional studios, only incandescent lighting is used. By the way, traditional fluorescent lighting fixtures are relatively quiet, unless the bulbs have been replaced with LED substitutes. I'm all for saving energy with new lighting technology, and I use it extensively in non-audio critical applications, but you need to be aware of this potential noise source. Another major electrical noise source is light dimmers. Dimmers produce the same sort of noise as LED bulbs, and usually cause similar problems in the studio. Dimmers, LED bulbs, and other common devices work by chopping the incoming electrical power into short segments. That contains a lot of unwanted energy that can affect a wide range of electronic equipment. In my studio, I found that the LED bulbs that came with the light fixtures were so noisy that the buzz even got into some of my ribbon microphones. I replaced the bulbs with incandescent bulbs, but they produce a lot of heat, and sometimes were too bright for the session. I installed a dimmer, one that purported to be electrically quiet, but the dimmer electrical noise was intolerable. I use a portable AM radio as a noise detector to see how far this noise traveled. I was amazed to discover that the noise was strong throughout the building. Evidently, the noise was radiated by the building AC wiring. And the dimmer does not have to be in your studio. It could be anywhere in your house. My problem was solved by using a rheostat-type dimmer, which is completely noise-free, but at a price. The rheostat dimmer was about 10 to 20 times the cost and much larger. If you want quiet lighting, I would suggest incandescent bulbs without dimmers, or, if dimmers are necessary, use the expensive rheostat type. There are other potential noise sources you might have to deal with. Most wall wart types of plug-in power supplies use switch mode voltage converters, and unless well designed, and that means expensive, they can create electrical noise, very much like the dimmers and the LED bulbs. Despite all these challenges, you can still get excellent results in your home studio as long as you understand the principles of soundproofing, sound absorption, sound diffusion, and the proper HVAC and lighting techniques. These are the major contributions to good or bad sound in the home studio. There are others, but these should be your first considerations. Addressing these things will not only make your recording sound better, but will also make your recording environment more comfortable. These things are key to providing a creative atmosphere, and what could be better than having a recording setup that is always convenient and ready to go? This is my take on music recording. I'm Doug Fern. See you next time.